When measuring a precision polygon, there are two things to be taken into account. The actual rotating table itself has very small errors, even though we do have an error mapping correction. So when we say go to 30 degrees, it may not go exactly. When we go to 60, it may not go exactly. But what we would like to see is that it repeats this in a systematic error. The same as a polygon. It may have a face which has an error, and as that rotates, we see that error rotate with the polygon. What we can therefore do is put the polygon on and measure at each 30 degree and including the first face again. So a 12-sided polygon will be measured 13 times. Then we can rotate the polygon by 30 degrees and do the whole measurement sequence again 13 times. For each of those faces, we can then build up a database which will help separate the errors from the table and the polygon. We can then go into error separation software. There are four sets of results. One are adjacent errors, which is the face-to-face error from the last face to the present. The incremental error is the error from 0 to the current face, which happens to be the sum of the above. The pyramid error is the maximum and minimum Y variation from the 0 position. And the drift looks at how repeatable the 0 and 360 degree, which should be the same, is, and we look at the maximum of all cycles.